Hello everyone. Today we are going to see the part programming for drilling operation. That is one more example. But before that, let us see the difference between NC machine and CNC machine. Okay. So in NC machine, NC stands for numerical control, and in CNC machine, the CNC stands for computer numerical control. In NC machine, the machine is controlled by the set of instructions in the form of numbers, letters, and symbols. And this the set of instruction is called as a program. And in CNC machine, the machine controls the motion of the workpiece and tool with the help of prepared program in computer. The program is written in alphanumeric data. In NC machine, the programs are fed into the punch card, and in CNC machine, the programs are fed directly into the computer by a keyboard. In NC machine, modification in the program is difficult because in NC machine, the program is fed through a punch card, and in CNC machine, the modification of the program is very easy. As we have seen before this lecture, we made the part program and we have given the sequence number, that is N0050. We have seen N010, N015. We maintained the gap that either 5 or 10. Why? If some modification is required, then we can insert that sequence number in between the present block. We assign the in between number to the modified block, so we can insert that modified block into the program. So the modification of the program is very easy. Okay, that's why we keep the sequence that 5, 10, 15, 20, or 1, 10, 20, 30 in such a way. So if any certain modification is required, we can insert the new block in between them. So the modification of the program is very easy. In NC machine, a high skilled operator is required. In CNC machine, a less skilled operator is required. As we have seen, once we feed the program into CNC machine, we can use a less skilled operator. Only his role is to load and unload the workpiece or job. Okay. Now let us see the cost point of view. The cost of the NC machine is less, and comparative to a NC machine, the cost of the CNC machine is high. Now the next point, we'll see the maintenance cost. The NC machine's maintenance cost is less, whether here on in CNC machine the maintenance cost of CNC machine is high. Now in NC machine, the programs cannot be stored. Okay, but in CNC machine, the programs can be stored in the computer and can be used again and again. Okay, so you can recall the program at any time, that is by using a subroutine and calendar cycle. We will see in next lecture what is subroutine and calendar cycle. Okay, in NC machine, it offers less flexibility and computational capability, and in CNC machine it offers additional flexibility and computational capability. In NC machine, the accuracy is less as compared with the CNC machine, and the accuracy in CNC machine is high. Now let us see the time point of view for the execution of the job. In NC machine, it requires more time for the execution of the job, and in CNC machine it takes very less time in for the execution of the job. Okay, because during whenever there is idle cut is there, we move the tool rapidly, so whatever the time required for the tool movement is a less. Okay, in NC machine it is impossible to run it continuously. So NC machine is difficult to run it continuously, but CNC machine can run continuously for 24 hours a day. Okay, so these are the differences between NC machine and CNC machine. First is their long form, second is their input. Okay, third point is their working, that is the punch card and the program. Okay, and next is modification in the program, and next is skilled operator point. Next point is the cost point, after that maintenance cost point, then the program store point, next point flexibility point, and next accuracy, and next is the time required for the execution of the job, and next the running. Okay, so these are the few points, the difference between the NC machine and CNC machine. Okay, now let us move to our part program of the drilling operation. So here, as you can see, the plate is given, which is having 70 by 40 and having 10 mm thickness, and it has 3 holes on the plate, which is having 8 mm diameter. Okay, so here for this I have already prepared a program. Let us see the one by one. Okay, the set of instructions, let us see the one by one block. Okay, but before that, if you observe over here the horizontal is considered as x-axis and vertical is considered as a y-axis. Okay, and whatever the drilling axis is there, it is z-axis. Okay, the spindle axis. Now let us see the program. Here it is the program, but let us see the side by side. I have, okay, here it is. So P1 is, as we know, it is for program identification number. Okay, now N is a sequence number. We have started the number with N005. Okay, then G90, G94. Now here G90 is for absolute system and G94 for a, it is for a feed per minute. Okay, and after that the next block N010, M06T2. M06 is for a tool change, and T2 for a selecting the our drill tool. Okay, now after these two blocks, the third block is there. Okay, M08, M03, S800. Okay, here M08 is nothing but the coolant on. Okay, whatever the coolant is there, we are going to use for drilling operation over here. That's why we have used the M08. Okay, and after that M03 is decides the direction of the rotation of the spindle. So here M03 is the clockwise direction, having the speed that is 800 rpm. S800, that is 800 rpm. Okay, now let us see the next block. Next block is N020. Okay, N020. Here we have taken the G00. First, that is we are going to take it as a safe position, initial safe position, that is x minus 5, y0, z3, f200. Okay, that means the tool move at this position. Here I already told you the here 00 is there, so initial point is our over here, x minus 5, y0, z3. Okay, z3 means it is above the workpiece, 3 mm above the workpiece. Okay, now next Now we are going to move the tool to our first hole. Okay, so here you can do one more thing also. You can write on one of the side over here the coordinates of the three holes. Okay, in our previous example we have seen, we have written the holes 1 2 3 and their x coordinates and y coordinate. So while writing the program it will become easy. So whenever possible write down on here the x coordinates and y coordinates. Okay, now first we are going to move the drill tool from safe position to first hole. Now from here to here, so this is our first hole. See, the coordinate is x coordinate is 10, y coordinate is 10. Now we are going to move our cutter from, sorry, tool from drill tool from here to here. So that's why we are supposed to make a next instruction, that is N025 G00 X10 Y10 Z3 F200. Okay, so 200 mm per minute. In such a way we have shifted the tool from safe position to the first hole's coordinate. Now we are going to insert the drill bit into the plate. Okay, so here we have used the next block, that is N030 G01 X10 Y10 Z minus 13 and feed 100 mm per minute. If you see here, the thickness is 10, but we are moving below that plate, that is 13 mm. We have taken the 13 mm, so you can take either 12 also. Okay, so to make a drill throughout. Okay, that's why I have taken 13. Now the position is that the the tool is inserted inside the workpiece. Now we are supposed to retract the position of the tool, so we have used the next instruction N035 Z00 X10 Y10 Z3 F200. Okay, while during drilling operation we reduced the speed, but during retracting position we just increased the speed because it saves the time. So now at this position we have made one hole, the which is having a coordinate x coordinate 10, y coordinate 10. So here our first hole is drilled. Okay, now we are going to move to our second hole. Now you are supposed to check the coordinate of the second hole and you are supposed to calculate. Now if you see the second coordinate, the second hole's coordinate, that is x coordinate is 60, y coordinate is 10. Okay, so now you are supposed to move the tool from 1 to 2. So we are going to move it rapidly. That's why we have used the code G00 X60 Y10 Z3 F200. Now tool is moved rapidly to the second hole position. Okay, or second hole coordinate. Now the tool is above the workpiece. Okay, now we are going to insert this drill into the workpiece. So we have to give the next instruction to the machine. So then the next block, that is N045 G01 X60 Y10 Z minus 30 F100 mm per minute. Okay, now the drill is inserted inside the workpiece. So for N045 position, for N045 block, the drill is inside the workpiece. Now we are supposed to retract the tool. So we are going to retract the tool over here. We are going to remove the tool above the second hole. Okay, so next set of instruction, sorry here by mistake I have taken the N045, but you can correct it, that is you can take the next N050 and go on continue. Okay, so here we are going to remove the tool which is inserted to the second hole. So G00 X60 Y10 Z3 F200. Now the current position of the tool is above the second hole. Okay, so now we are going to move the tool from second hole to the third hole. Okay, so we are going to give the instruction next, that is G00 X60 Y30 Z3 F200. Okay, here we have given the instruction to the machine, that is tool should move from X60Y10 to X60Y30. Okay, now the cutter is above the third hole position. Okay, now we are going to insert the tool into the workpiece. We are going to drill the third hole. So here the value of the Z will be changed. So here you can see Z01 X60 Y30 Z minus 13 F100 mm per minute. Now third hole is drilled. The current position of the tool is, it is in the workpiece, it is inserted into a third hole. Now we are supposed to remove the tool outside the workpiece. So for that we are supposed to give the next instruction, that is we can see next block G00 X60 Y30 Z3 F200. Okay, F is nothing but a feed. Okay, so for after this the position of the drill is above the workpiece of the third hole. Okay, so in such a way we made a 3 holes in the workpiece. Now after this we are supposed to move the tool to our safe position. So we are going to give the next instruction, that is the tool should move to its safe position, its initial position. And the initial position, as we have already know, we had given it in N020. So next instruction is Z000 X minus 5 Y0 Z3 F200. Okay, in such a way the drilling operation is performed in the workpiece, and now currently the tool is at safe position. Okay, so after this we are supposed to stop the coolant. Okay, so for that we have used the M05. M05 is for a spindle off. Okay, M05 for spindle off and M09 for a coolant off. Okay, M09 for a coolant off. Now after giving this instruction, the spindle becomes off it stops rotating, and the coolant will also become a off. And the last is M02, that is nothing but a end of the program or program end. Okay, so in such a way we can do the programming for a drilling operation. Okay, but here if you observe, I am also today going to repeat that in this program there are three major parts. Part 1 is program setup, second part is chip removal, and third part is system shutdown. Okay, so here are the programming for the drilling operation. Okay, now I am going to repeat the codes which we have used in the part programming. Okay, P1 first, it is for program identification number, N is for sequence number, G90 G90 is for absolute system, and G94 for a feed per minute, M06 for a tool change, and T2 for a current tool. Okay, that is in M06 T2 means we are going to change the tool to our current tool, that is T2. Okay, now M08, that means we are going to make a coolant on. Okay, and M03 is a spindle rotation, that is in a clockwise direction, M03, and S800 is a 800 rpm. Okay, and G00 is for a rapid transverse movement, G01 is for a linear interpolation, M05, okay, it is for a spindle stop, M09 for a coolant off, M02 is for a program end. Okay, so here you can see, but I will repeat shortly. Okay, so from N05 to N015 we did the setup for the program, that is we selected the system, that is absolute system. We have given the feed which is in per minute by using the G94 code. We have changed the tool by using M06. Then we started the coolant on M08. Then we have given the direction, the rotation to the spindle, that is clockwise direction, and having with the speed of 800 rpm. Such program setup we made in first three block, and next we moved the tool initially to a safe position. Okay, in fourth block. Okay, first we moved the safe position, then we moved the tool above the first hole position. In next block we made a drill into a first hole position having the coordinate x coordinate 10, y coordinate 10. Okay, after in next instruction, in next block we removed the tool from the workpiece, that is x10, y10. Here we have removed the tool from the workpiece, and in next block we moved the tool from first hole to second hole having the coordinate x coordinate 60 and y coordinate 10. Here we moved the tool from first hole to a second hole position. Okay, and after that we made a drill that we have given the instruction in next block, that is here you can see it is inserted into the workpiece. Now we are supposed to remove the tool from the workpiece that we have given the instruction over here, that is drilling is now it is drilling is over at the second hole position and it should come out. So here the tool position is above the second hole position, that is having the x coordinate 60 and y coordinate 10. Till now here the two holes are completed. Now after second hole we are going to move the tool from 2 to 3. Okay, and here the second hole's x coordinate are x coordinate is 60, y coordinate is 10, and now the third hole coordinate is x coordinate is 60, y coordinate is 30. So here we moved the tool from second hole position to third hole position. Now after this block we are going to insert the drill into a third hole position. So here we are given the next instruction that the tool should insert into a third hole, that is drilling can be performed at third hole position. Now at this stage the position of the tool is now inserted into a workpiece. Now after this we are supposed to remove the tool from the workpiece. So we are supposed to give the next instruction. So here it is given in a next block, that is the drilling is performed. Now it can come outside the workpiece. Okay, in such a way at this stage the three holes are completed. Okay, now after this we are going to move, or we are going to shift this tool to a safe position. Now safe position we have already defined over here. It's that is x coordinate is having -5, y coordinate is 0, okay, z coordinate is 3 mm. So here we have moved to a safe position. So here our second part is completed, that is the chip remote process is completed over here. Now at this stage the drill tool is at a safe position. Okay, now our the chip removal is over. Now here it comes the third part, that is the system shutdown. Okay, now we are going to first of all stop the spindle. So that's why we have used this M05 code to stop the spindle. And now after that we made a coolant on. Now we are supposed to make a coolant off. Okay, so to make a coolant off we have used the M09 code over here. Okay, so now the spindle is stopped, coolant is stopped. Now we are supposed to say that is program end. So we have used M02 code at the end of the block, at the last block of in the program. Okay, so here you can see the carefully horizontal axis is x-axis, vertical axis is y-axis, and whatever the drilling spindle's axis is there, it is a z-axis. Okay, in such a way you can do the programming for any drilling operation, for any plate or whatever the workpiece is there. Okay, so here you can see the hole is inside, you can see the hole is made throughout. Okay, so here so I said that I have taken 13 mm, you can take either 12 mm or you can take 14 mm also, but what happens, it consumes the time. That's why you are not supposed to take much more distance, and you are not supposed to take a less distance also. Okay, so you are supposed to take a proper distance that the hole can be made throughout and in short time. And during return position you are supposed to use a rapid transverse code, that is G00. Whenever cutting is there you can use a G01, but when only the travel of the tool is there, okay, without cutting, at that time you are supposed to use the G00 code. Okay, this G00 code is for a rapid transverse movement. So tool moves tool moves fastly. Okay, here even though if you can see, whenever their drilling operation is there, here you can see for first hole, for second hole, for third hole. Okay, only during this operation I have used the G01 code. Okay, only after that, if you see in other blocks, here here I have used the G00 code, because it saves the time, and time is important in industry. Okay, whenever there is no cutting, first I am going to repeat it once again. Okay, so in any part programming there are three major parts, and three major parts are there, and they are important. First one is a program setup. You are supposed to set the program, that is spindle rotation, tool change, coolant on. Okay, and next part is chip removal, that we have seen over here. Here you can give the instruction for the chip removal, and after that the third part is a system shutdown, means whatever the uh, program you set, that is spindle on, coolant on, that you are supposed to make a off, and at the end you are supposed to mention that the program end is there. Okay, and here you can do one more thing, that whenever you move the tool rapidly by using a G00 code, you can use the you must use the feed rate as high. Okay, and during cutting you are supposed to reduce the feed rate. Okay, so only for the to save the time. Okay, this is what we have seen, the example for the drilling operation, that is part programming for drilling operation. Okay, so this is what we have seen. Now we are going to stop over here. Thank you.